2014 Paper 2 Question 4. What we'll do to a calculator, we'll go to a calculator page and we'll define all the vectors that have been given. Now we're given the coordinates of A, so I can define the vector OA to be the vector by pressing control template to get colon equals. We'll then go to the vector template which is there, and we'll type in 8, press tab, 0, and to get the next row we press carriage return. It's the bottom button in the bottom right hand corner of the keypad to the right of the letter U. So there's OA. Let's just go back in, press enter and edit this to be OB. So we have that available, so that'll be 11, that'll be 4, and that'll be 2. For getting the position vectors of OC and OD from reading off the diagram and doing a little bit of thinking, OC will be 11 as well. Then it goes 12, and then it goes 6. And OD, we go highlight that, its position vector will be 8, 8, and 4. So we've got the coordinates of C and D. The coordinates of C would be 11, 12, 6. Coordinates of D is 8, 8, 4. Now the components of CB, CB could be defined as being equal to OB minus OC, which will be that vector there. And CD could be defined as being equal to OD minus OC, which is that vector there. So to work out the vector BCD, we've got to use the vectors CB and CD using the scalar product. So the scalar product is, just to write it out in normal parlance, it will be CB dot CD would be equal to the magnitude of CD, which would be that one there, multiplied by the magnitude of CB, got the other way around, not too much of a trauma, and then multiplied by cos of whatever the angle would be. Let's call it ang. So that's the process we're going to have to go through. So we're going to have to evaluate this, evaluate those two lengths, and then do inverse cosine. Now when I press enter, it'll give me an error because it doesn't know about half of that stuff. So what I'm wanting to do is, let's just work out the dot product of CB and CD. The way to do that is menu, matrix and vector, and if we go all the way down to the bottom of the list, we get vector, and we've got dot product. So the dot product of CB, comma CD will be the number 40. Now I need to work out the lengths of these vectors as well. So I can do menu, matrix and vector, and where it is actually is under norms, and it's the norm of the vector. So that'll be norm of CD is that number, and norm of CB will be that number. So in order to work out the angle, we're going to have to set up a fraction template. We're going to have to do the dot product on the numerator, like so. And I'm just going to go over that, press Control C to copy it, and then Control V to paste it. Does that work? I hope so. Nope, not quite. Let's try it again. So I go up over the statement, norm CD, copy it, down to the denominator, paste it. There we go, it worked this time. Then multiply by, well, I'll just paste it again and then edit it. So this is going to be the statement when I divide both sides by the magnitude of these vectors, and then I'm going to do inverse cosine of this. So when I press enter, I get there. I better just check I'm in degree mode. Yes, I am. So inverse cosine of that whole expression will give me an angle of 33.85. And there's been no loss of rounding errors or anything like that all the way through. That is an accurate answer. Does that look appropriate? BCD, it does look like a fairly small angle, 33.85. If their diagram is good, it seems plausible. We're done.